This is Lesson 1-2, Order of Operations and Evaluating Expressions. The learning targets today are to simplify expressions involving exponents and to use the order of operations to evaluate expressions. There are 5 vocabulary terms that we are going to talk about in this lesson. First, we will go through and define each of them, and then I will use a diagram to help you better understand. A power is the base and the exponent of an expression of the form a raised to the n. Exponent is a number that shows repeated multiplication. Base, a number that is multiplied repeatedly. Simplify, to replace an expression with its simplest form. When you are simplifying, you may not always come up with an actual answer. You're just going to complete any operations that you can to simplify or reduce the expression that you are given. Evaluate, to substitute a given number for each variable and then simplify. The example that you see in front of you is going to help you understand some of the vocabulary words. 2 to the third power equals 2 times 2 times 2. Well, you've been learning that for many years now. The confusion with the vocabulary terms are usually the fact that it's read 2 to the third power. However, 3 is not the power. The whole term is considered a power. With the 2 being the base and the 3 being the exponent. So if we go back and look at our vocabulary terms, power says the base and the exponent of an expression in the form a to the n power. So you can see how it is the whole term is what makes up a power. Exponent is a number that shows repeated multiplication. The exponent is telling you how many times you multiply. The base is a number that is multiplied repeatedly. So that's the number that you multiply by itself. Now we are going to practice simplifying powers. And our vocabulary word simplify told us to replace an expression with its simplest form. The directions read, what is the simplified form of the expression? So first we will take a look at a, 10 to the 7th power. This means that we multiply 10 by itself 7 times. When we multiply 10 by itself 7 times, we get the answer 10 million. In problem B, we're going to multiply 2/10 by itself 5 times, and our answer is going to be 32 hundred thousandths. And finally, in example C, we're going to have 2/3 times itself 3 times. Now we have to remember how to multiply fractions, and we just multiply all the numerators. 2 times 2 times 2 is 8. And we multiply all the denominators. 3 times 3 times 3 equals 27. So 2/3 raised to the third power equals 8/27. You learned the order of operations way back in elementary school when you learned about PEMDAS, or Please Excuse My Dear Aunt Sally. I like to use GEMS instead. I think it helps alleviate some common mistakes. So if you perform operations inside grouping symbols, and the G from GEMS is for grouping symbols, because now we don't just use parentheses. Simplify exponents, multiply and divide from left to right, add and subtract from left to right. We're going to do 3 examples practicing using the order of operations. 6 minus 2 raised to the 3rd power divided by 2. We first need to look inside our grouping symbols. 6 minus 2 equals 4, raised to the 3rd power divided by 2. Now we go to our exponents. 4 to the 3rd power equals 64, divided by 2. And then our last step would be to divide 64 by 2, which equals 32. Example B. There's no visible grouping symbols here. However, when you see a problem like this, the division bar or the fraction bar is considered a grouping symbol. We would first do everything on top and everything on bottom separately before we would actually do that step of division. So since that's our grouping symbol, we're going to look at the top of the expression and we would go to exponents. 2 to the 4th power equals 16. So I rewrite the expression. Again, I continue to finish solving the problem in the numerator. 16 minus 1 is 15. And then lastly, I would do 15 divided by 5 and get my final answer 3. In example C, we don't have any grouping symbols, so we would start immediately with exponents. 4 to the 2nd power is 16. Now I have multiplication and division, but following my order, I do it from left to right. So I would do 5 times 7 equals 35, minus 16 divided by 2 equals 8. And the last thing I would do is subtract. 35 minus 8 equals 27. Next, we will be evaluating algebraic expressions. Now, if we look back to our definition for the word evaluate, it said to substitute a given number for each variable and then simplify. In this particular set of examples, it says what is the value of the expression for x equals 5 and y equals 2. So we will plug in 5 for x, y for 2, and solve. So the first thing I do is write my expression with the numbers instead of the variables. 5 squared minus 5 minus 12 divided by 2 squared. Now we can work through our order of operations. There's no grouping symbols, so we would go right to the exponents, and we get 25 minus 5 minus 12 divided by 4. Now there is no multiplication, however there is division, so we have 25 minus 5 minus 3 because 12 divided by 4 is 3. Now we can simply answer by subtracting from left to right. 25 minus 5 is 20. Minus 3 will give us a final answer of 17. Example B, we substitute 5 in for x and 2 in for y, so we have 5 times 2 in parentheses squared divided by, now when we see variables next to each other, that is just multiplication, 5 times 2. Now following our order of operations, we start with the grouping symbol. So 5 times 2 is 10 squared divided by 5 times 2. We now go to exponents. So we have 100 divided by 5 times 2. Multiplication and division goes from left to right. So 100 divided by 5 is 20 times 2 gives us a final answer of 40. Example C. We're going to plug in 3 times 2 to the third power times 5 plus 5 divided by 5. Now we start inside the grouping symbol on top of the fraction bar. Remember, the fraction bar is its own grouping symbol, meaning that you would calculate the top before you would divide by the bottom. So 3 times 2 is going to be 6 to the third power times 5 plus 5 divided by 5. 6 to the third power is 216 times 5 plus 5 divided by 5. Now we have to do 216 times 5, which is 1080, plus 5 divided by 5, and we're left with addition on top, so we get 1085 divided by 5. We divide 1085 by 5 and get our final answer of 217. Evaluating a real-world expression. What is an expression for the spending money you have left after depositing 2/5 of your wages in savings? Evaluate the expression for weekly wages of $40, $50, $75, and $100. First, looking at the actual problem here, the word of is going to tell us to multiply. In order to find 2/5 of a number, we have to multiply. Wages is what we're talking about, so we're going to let W equal wages. And now let's think about what we're trying to find. The amount of spending money you have left. Well, if you think about how you're paid, you get your wages, and now we're depositing 2/5 of that into savings. So that means we're going to take away 2/5 of our wages, so it's multiplication, and that's going to tell us how much spending money we have left. Now it's an expression, so we're not putting an equal sign. So I'm just drawing that arrow so that you understand that that expression is equaling our spending money. So we're just going to rewrite what is our actual expression. And it is W minus 2/5 W. Now they want us to evaluate the expression for weekly wages, so I'm going to make a table to organize my data. And my table is going to be called spending money. And it's going to have 3 columns. The first column is going to be wages, which we called W. The second column is our expression, W minus 2/5 times W. And the last column is our total spending money, because that's what that expression gives us. Now in the problem they told us to evaluate the expression for weekly wages of $40, $50, $75, and $100. So we simply just put those values in for wages. So 40 minus 2/5 of 40 gives us $24. And I'm going to put a dollar sign at the top of my table so that I understand that this column represents dollars. Now we do 50 minus 2/5 of 50, and that's going to give us $30 spending money. 75 minus 2/5 of 75, that's going to give us $45. And last, if we made $100 in wages minus 2/5 of $100, that would give us $60 in spending money. The remainder of your homework assignment is to complete these 5 problems listed under your turn. You can always go back and view the examples that I did to help you along. Have a great night. See you tomorrow.